Hello everyone. Today we are starting a fascinating journey into the world of fluid mechanics with the goal of understanding one of the most important in the field, the Navier-Stokes equation. So, where does this equation come from and why was it introduced? Well, think about a fluid, maybe water flowing in a river, the air around us, or even the blood flowing through our arteries. We want to understand how each particle of the fluid moves, interacts with external forces, how physical phenomena such as turbulence, viscosity, or pressure arise. This is exactly why the Navier-Stokes equation was formulated to describe and predict these types of motion. So to start, let's consider a small material fluid element of volume delta V. This is our fluid element, V velocity. Delta V is the volume. Delta V equals delta X times delta Y times delta Z, or the density and the mass of the fluid element is given by delta M equals rho times delta V. So the goal is to perform a force balance to identify the forces acting on this fluid element. And according to Newton's second law, the product of the mass and the acceleration equals the sum of the forces acting on the fluid element. We can write that delta m times acceleration equals the sum of forces acting on this fluid element. So these forces can be classified into two types: body forces and contact forces. For the contact forces, there are two types: pressure forces and viscous forces. Viscous forces. So now we're going to derive each force acting on this fluid element. So we start with body forces. Here we will only focus on gravity as a body force. Gravity So the gravitational force acting on this fluid element is delta F sub G. Delta F sub G equals delta M times G which is rho times delta V times G. So the key idea here is that to work in the Navier-Stokes equation framework, we define forces per unit volume. At this point, we can write the gravitational force per unit volume is F sub G equals delta F sub G. We divide by the volume delta V over delta V equals rho times delta V times G over delta V, which is rho times G. The gravitational force per unit volume is rho times G. So, I want you to keep in mind that other body forces may exist depending on the physical problem, and these common body forces include inertial force, inertial force, inertial force, inertial forces which appear in a general non-inertial reference frame due to the acceleration of the frame. There is also Coriolis force. Coriolis force which arises specifically in a rotating reference frame such as the Earth, and we can add the Lorentz force, which acts on a fluid particle subjected to a magnetic field. So now let's move on to the contact forces.